Hi, we're going to continue our discussion in chapter 4, moving on to section 5, that's a local variable. So that's what we're going to be talking about in this video. We're talking about the functions, and what we're talking about is when we are declaring variables inside the function, those variables are local to that function. That means what? You cannot see it anywhere else. So that variable that's created inside the function cannot be seen some other places. Advantage of that is if you have different functions that they have the same variable names, they're not going to overlap each other. So they totally are separate locations. So the scope of that variable is inside of that function. That means when you go inside the function, that variable is going to be born. And when you finish the function, the variable is going to go away. So that's what the scope is. So if we declare it in the main part, remember the main also is a function. So whatever variable we're declaring in the main is going to be in the main. So the scope of those variables are inside the main. So the main is the scope for that variable. So if we go to look at this one, first let's look at, let me get my annotation over here. So what we're talking about is if I have an average P here, this average P belongs to this function. So if I have another average P, like this one in here, these are not the same. You can think about two people who have the same name. Even though they are called the same thing, they are not the same. So when I'm using this in the main, it's not going to be the same as this. So the mistake that a lot of new programmers do is they forget to declare the average P, and they just calculate this average P over here, and they expect it to come up and be available somewhere in the main, which is not true. So what can we do? We can create global constants that would be above main. The global constants can be visible to everything underneath. So if I create a global constant above the main, it's visible in the main, and it's going to be visible in all the functions. So the good thing about it is what? Every function can see it. The bad thing about it is if you move that function to another location, another program somewhere else, you have to remember that global constant has to go with it. So in the future chapters, you're going to learn how to create a header file and how to put your global constant in the header file. And every time you move your CPP file, you're going to move your header file as well. So it's outside of any function body, and it's declared outside of main. So every function can use it. So this is an example of that. We have our main over here. Above main, we have our function declarations. Of course, we should have comments in there, but for now, for the space purpose, we don't put the comments in there. And this one is above anything. So that means this pi that's declared over here as a constant global, it's going to be visible inside the body of the volume. It's going to be visible inside main. So all of them can see it. So the example that you have in your book, that would be my constant global variable. And then this one is not only going to be available in main, is going to be also available in our functions. So in this case, we are using the pi in two different functions, and it's going to have the same value because it's constant. I cannot change it because it's constant, but it is visible everywhere inside this function, inside the main. We can have variable in the global side too. So we can declare variable in the global, meaning it's above the main, and it's going to be visible to everything. Some of the new programmers, what they do is when they figure out that they need something inside of this function in another function, they go and create it above the main, use a global variable. So it's just like a global constant. It is above main, but the bottom line is do not use it. So for a few reasons. One is your functions is not portable anymore. Two, at this chapter, we are practicing on communicating through parameters. So if you want something in a function that's going to be available in another function, you have to have a return value for it and then use it as a parameter on the other function. So in chapter 4, we are just learning about function with one return value, and we can have parameters in it. So you're going to be practicing on that for now till we learn chapter 5, call by reference. That's the only way you can use a variable that's inside a function. Inside another one, you can call it. We can call a function inside another function, or we can call them in the main. So we can call a function, get the result, pass it as a parameter to another function, get the result, you pass it as a parameter to another function. That would be the good structure. But the bottom line is, in this class, you are not going to be using global variable at all. So when we're talking about the parameters for our function, they are actually local variable, and that's why we call them call by value in this chapter, because they are created as you creating your function. Remember, when you do a function call, it's going to go inside the code and it's going to execute the code that's in there. So those parameter becomes local to that function. It's going to come alive when the function is called, and then it's going to go away. It's going to be a little bit confusing at the beginning, but we're definitely going to get it. The big thing that we have to be careful is when you have it as a parameter, you shouldn't be declaring it again inside. You can do it, but then you have two variables with the same name, which is going to be very confusing. Sometimes when you need a variable and you see it doesn't, and you mix the names, that's what happens. So do not redeclare it. Of course, the newer compiler is going to catch that, and it's not going to let you do it anyway. So that's basically the call by value mechanism, and we're going to talk more about that. So let's look at this program. Let me move these. So this is a display 413 from your book. And so first thing we see is what? We're going to see the global constant above main, all the way on the top. We're creating global constant in there. So we're putting the rate over here. Then what's the next one? We're going to have the function header or function declaration over here with the semicolon. We're going to have our comments right after your function declaration. Remember that the future developers and yourself, you're only going to see this. You're not going to see the code for the function. So your comment and the name of the function should be descriptive enough for people to understand what is this function going to do. And then, of course, we're going to have some description of what is this doing, what's going on with the program, what are we expecting from the user. And then we're going to be reading hours and minutes. And then we're going to call this function called the fee. You did a program very similar to this in the previous chapter. We didn't use a function. We didn't know how to use a function. So we are reading hours and minutes. So for the sake of discussion, I'm going to put the hours for 2 and minutes for 10. So I'm reading 2 from the user, and I'm going to take 10 for the minutes. So when I call the function fee, the 2 for the hour is going to go there, minutes 10 is going to go there. So what's going to happen is going to jump into our function definition. So the 10 is going to come here, and the 2 is going to be right there. So this 10 goes into minutes work. Remember, this variable doesn't have to be the same as this, especially because it's going to be portable. And the reason we don't want to, you can call it the same thing. We just want to be sure you don't get confused and you know there are different variables. So this minutes 10, we're going to copy it and put it in this minute work as 10. Now, that 10 is going to be used in with hours. We put a 2 times 60, 120 plus 10. That should give me my minutes work 130, and we're going to calculate the quarter hours. Now you can see my minute has changed inside here. So when I go back up after this function call, my minute is not changed to 130. It's going to stay at 10. That's called by value. So my minute before function call and after function call is going to stay the same. So we talked about the function, that everything inside the function is going to be local to the function. Actually, we can extend that the local variable are local to the block of code, not to function only. So we can have code inside a code, block of code, and your block of code are separated by braces. So anything you put in the braces is a block of code, and your local variable is local to that block of code. So let's look at that one. So we have these things over here. So we have this global constant defined as 1. So because this is above everything, this is going to be available to everything in here. The main functions all. And then we're going to be having a function 1, and we're going to have a main. So inside here, inside the main, I am having another word constant that, or not a constant, I have a variable that I'm going to assign it to the constant variable. Now, I have a block of code here, which is going to be calculating this x over here. Because this x is declared outside of this function, for loop, then the x is going to, even though it's local here, it was declared in here, so it's going to come out of this. Now, if I would have declared this x inside here, if I had an int x equal function 1, then that would be different than this x. And here we have the local variable to this function. So every block of code can have its own local variables, and if it's declared inside of that block of code, it's only going to be visible to that particular block of code. So we talked about the using namespace, and remember that when we're using a namespace, we're doing that. We were using it in global. So again, the problem is going to come up just like your global variable or global constant, that if you're moving your function, you have to be sure that the using namespace is going to go with it. So one way to fix that issue is we can make the using namespace std as local instead of the global. So whenever we need it, we can use it. So we can have it in the main and use it inside the main, or we can have it inside the functions. So we have input, processing, output, or input and output are the only ones that are going to use C in, C out. So we can use the using namespace std inside the functions. So when we're moving these functions, we don't have to worry about moving global variable with it. It's already going to be part of it. So different way of doing it. I'm not worried about this too much for this class. So I'm going to keep using the global using namespace. All right, so we're going to do this as an activity. So I want you to think about this, or write it and compile it. It shouldn't take you that long, but maybe a little bit of thinking. I'm twisting it a little bit different than your book. So we have a factorial. What is a factorial? Factorial and factorial is 1 times 2 times 3 times 4 times up to the n. So if it's 4, it's going to be 1 times 2 times 3 times 4. So that's factorial. So when we want to write a function to do factorial, we're going to have one argument, what is the n, to come to my function. And then, of course, it's going to return the factorial value. We're going to have a local variable called product inside of this function. So I want you to create a declaration, and I want you to create a function definition for this. So I am asking you to use a for loop for this. Your book is using a while loop, which is fine, but I want you to practice on the for loop. And we're going to do a backward for loop. That means we are not going to start with 1, we're going to start with n, and we're going backward. So we're going to have n, then we're going to multiply it by n minus 1, then we're going to multiply by n minus 2, and so on and so forth. Remember, you can start with n, and excuse me, instead of plus plus at the end, you're going to say minus minus. Okay, so that would be your activity, and we're going to work on it in the class when we meet again.